Another way that you can solve systems besides graphing, which is, while visually the easiest to comprehend, it can take a lot of time. It can also be a big challenge if you have to be precise and the numbers aren't nice. So then we can solve systems by substitution. And now we have a third method, which is what we call elimination. So when we have elimination, we want to manipulate one or both of the equations so that if we were to combine them, one of the variables will be eliminated. It's going to be taken away. Just like with substitution, that gives us the ability to solve for one variable, and then we need to do work to then find the second variable. That second part is going to be going back and relying on substitution. So that's something that's already been covered. But the first process, eliminating a variable, is done in place of substituting. So in this scenario, we've got a negative 6x, a negative 5y, and that equals 17 for the first equation. On the second equation, we have a negative 3x, a positive 6y, and that equals 0. So we need to be able to, when we are going to add these two together, one of the variables needs to be removed. I see that we have a 6 and a 3. So if we made that bottom negative 3x become positive 6x, then when adding, those two would be taken away. For the first equation, I'm not going to do anything. It'll stay negative 6x minus 5y is equal to 17. For this second one, I'm going to multiply every single term by negative 2. Negative 2 times negative 3x gives 6x. A negative 2 times a positive 6y gives a negative 12y. And a negative 2 times 0 is 0. When I add these together, a negative 6x and a positive 6x is 0x's. So that is now gone. We've been able to eliminate the x's. Negative 5y plus a negative 12y is negative 17y equals 17 plus 0 is 17. This process has brought us to having negative 17y is equal to 17. I now need to get y by itself, so I'm going to divide by the coefficient of negative 17. Negatives become positive, 17s are 1. We get 1y is equal. Positive divided by a negative is a negative. 17 divided by 17 is 1. 1y, or y, is negative 1. That has been the elimination process. We eliminated the x to solve for y. Now, this will be just like when we were dealing with solving using substitution. We have our y, and we need to substitute it into one of the two original equations and solve to find out what is x. So I'm going to take the second equation. It doesn't matter. Negative 3x plus 6 times y, but y we're going to plug in or substitute in a negative 1. That equals 0. Negative 3x, 6 times a negative 1 is a negative 6. And now we need to isolate our x term. So we're going to add 6 to both sides. Negative 3x's equals 6. And dividing by the coefficient, which is negative 3, to get x by itself, 1x is equal to a negative 2. It would be smart to check our work and make sure that the solution that we have now found of a negative 2, negative 1 is in fact going to work out for both equations. So please remember, it is always in the form x comma y. If you give the solution as a negative 1, negative 2, that is a different point. It doesn't mean the same thing. We're going to plug in negative 2 for x, so we get negative 6 times negative 2, and negative 1 for y. Negative 6 times negative 2 is 12. Negative 5 times negative 1 is a positive 5. So 17 equals 17. That is true. It works for the first equation. Second equation, -3 times -2, and 6 times -1 means -3 times -2 is 6. 6 times -1 is -6. Does 6 take away 6 equals 0? Yes, it does. So that works out as well. We have checked our solution, and that is good. It is true for both equations. All right, let's do another problem. Again, we are going to be using elimination. I see that I could eliminate the x's. I can make them go away if I had a positive 2x on the bottom, because a negative 2x's, a positive 2x's would be 0. So I'm going to multiply the entire bottom equation by 2. I'm just going to treat this as a big distributive property, so that would be 2 times x is 2x. 2 times a negative y would be a negative 2y, equals 2 times the negative 5 is negative 10. The top equation, I'm not going to do anything. I'm just going to rewrite it. And so we can now add these together. Negative 2x's, positive 2x's is 0x's. Positive 2y's minus 2y's is 0y's. And 10 take away 10 is 0. So I have no x's and no y's, so I have 0 on the left, and 10 take away 10 was 0 on the right. 0 equals 0. I have no variables. I only have this statement. It is a true statement. 0 is always 0, which means when it comes to saying, well, what does that mean in terms of a solution? Where are these two lines going to meet? It's going to be a special case. It is infinite. Any point is going to work. If you're struggling to understand why, well, let's take it to graphical form. So I'm going to solve for y's to make it into y is equal to mx plus b. Negative 2x plus 2y is equal to 10. I'm going to add 2x's to both sides. 2y is equal to 2x plus 10, dividing by 2 to every term. Y is equal to 1x plus 5. And the second equation, we've got x minus y is equal to negative 5. I'm going to add y's. X is equal to negative 5 plus y, add 5's. So then x plus 5 is equal to y. I can rewrite that by flipping it. As y is equal to x plus 5. So already you may notice that they end up giving us the exact same equation. We are up here at 5, and you're going up 1 over 1 each time. And that's going to be showing us representing y is equal to x plus 5. So these two equations looked different, but when we rearranged them, we find that they in fact give us the exact same line. And that's why we end up getting this true statement, because if it's true for one equation, it will be true for the other, because they are the exact same equations. And that's why we would just say that there are an infinite number of solutions. No matter what value of x and its corresponding y is selected, we plug it in and it will work out for both of these equations.